So, hello and welcome to this month's GDG Gig City meeting.
Yeah, I said there was supposed to be a couple more people or something.
There was one more that RSVP'd, but it is 17 after, so I guess if he is coming, he can come in late. So, yeah. You guys all know me and know how to get a hold of me.
Okay.
And of course our code of conduct, which is summarized as being excellent to each other, but you can get to the full at ggggigcity.com/coc. So affiliates and sponsors for the group. Code Journeyman is providing the space for us to do the meetings. There's Chadev, which holds a weekly developer lunch every Thursday at the Edney building now. We have Manning Publication, and if you use the promo code UG376, you can get 36% off all purchases on their website. And they do really good stuff. What's that, Lee?
Is that for paper books too?
Yes, that's paper books and ebooks. Any purchases, you can get 36% off. Again, UG367. It's the same for the Wi-Fi.
Okay.
Is your browser in offline mode? Oh, don't do the guest. We haven't worked out that. Switch over to the internal. One of these two.
Oh, does the guest not work?
It's not routing, it seems. We may have a gateway issue on the guest.
Oh, I might not have fixed it.
So, upcoming events, our March meeting is on the 16th. There's currently no topic yet, so if you want to suggest a topic, just let me know.
Okay. How did that one last time, that virtual meeting last month go?
It went pretty well. We had Sean and Richard both joined live, and there was some technical hiccups, but we went through it. The recording is on YouTube if you want to go through and watch it. Okay. And then the slides, I can make sure that they're publicly available so you can go through the slides as well. Okay. All right. So there are no announcements for this month. So we'll get into the talk, which is discussing Go 1.6 and all that is new and all that's been changed in it. So let's over to that. Make this up. All right. So the February 17th was a picked date by the community to hold these release parties all over the world, and there are 50 user groups worldwide that are either taking part or have or will be taking part in this. The idea was 1.6 was going to release sometime in February, but it looks like it's going to be probably the next couple of days. And so they wanted to get these at least scheduled to make sure people knew about it. This presentation is heavily based off the release notes for it, and it contains a lot of links to further readings, so you can actually find these slides and go through them yourselves at this site as well. And I can post a short link to that if need be. So the 1.6 arrived 6 months after the 1.5 release because they release new versions every 6 months. Most of the changes are in the implementation and runtime in the libraries. There's no language specification changes, nothing that really affects the user base, so how the user sees the tool chains and everything has stayed the same. It has the Go 1 compatibility guarantee.
Yeah.
So any code that compiled for Go 1.4, Go 1.5 will still compile with 1.6. And almost all programs are expected to continue and run as before. So Go was announced as an open source project in November 10th, 2009. And the releases are on a 6-month schedule with several bug fix releases between each major release. So looking at the schedule, the Go 1 was in March 2012. 1.1 was May 2013. And it goes on. And as I said, 1.6 is going to be this month for sure.
Okay.
So Go 1.6 actually adds support for a few new operating systems as well as CPU architectures. So now supported operating systems are Windows, OS X, Android, iOS, Chrome's native client, which means it can run in the Chrome browser and Chrome OS, Dragonfly BSD, FreeBSD, Linux, NetBSD, OpenBSD, Plan 9, and Solaris/Lumios. As for architectures, it supports the x86 and x86_64-bit architectures, which is common for Intel and AMD, as well as ARM, the V5, V6, and V7s, which are typically seen in the cell phones and Chromebooks. ARM 64, 64-bit PowerPC, both big and little indent, 64-bit MIPS as well, and the same for them. The 390X, which is seen in the IBM Z series servers, are actually planned to be in the next major release. And RISC-V or RISC-V is being talked about being added.
For the operating system, that means that they've also got the binary for those.
Yes, so you can compile Go for them, and you compile your application for them.
I mean, you could possibly attempt to port somewhere else, but they've already supporting these.
Yes, these are officially supported. If you want to add a new operating system that already isn't, you can.
Okay. Wow. Okay. So they didn't do Android before, and they didn't do.
Android wasn't officially supported until they had the Go mobile libraries.
Yeah. Okay.
Before you could do it, but it was very hacky how you had to do it because you had to actually compile for the Linux base and use the ARM architecture, and you couldn't expose it to the UI, so the phone had to be rooted. Now you don't have to have that root.
I mean, can you actually have at some point apps with Go on Android?
Yes, there actually already is a test app, which is basically a re-implementation of a scientific calculator that's completely written in Go and uses OpenGL to present the UI for it. So there's already Android and an iOS app in pure Go.
So it's already starting to do that.
Yes, they've been working on getting that for a while.
Yeah, because I was looking at something like even more recently, maybe a few months ago, somebody said, "Oh, Go's never going to work with Android, perfectly. You can just do this hacky stuff with it."
Well, for a while, not perfectly, because a lot of the APIs are written for Java.
Right. Yeah.
And so what the Android teams are actually working on is also making Go bindings for their APIs, so both Go and Java can work with everything.
So that means at some point you should be able to do apps completely with Go?
Yes. You can now, there's some things you can and cannot do natively.
But it's moving that way.
Yes.
Oh, that's great. Yeah.
So one of the key features for that Go started with was the idea of cross-compiling. So with 1.4 and below, it was kind of a pain to get this to work because it used a lot of the runtimes and the compilers were actually written in C. And so you had to bless your Go installation by compiling a version of the compiler and everything for the operating system, the architecture you wanted to compile against. But since 1.5 and up, that's no longer the case because everything's written in Go. They got rid of all the C code. And so now you can just cross-compile.
That means there's no underlying C code anymore.
Yes, they got rid of that in 1.5.
Oh, okay.
And so to cross-compile, all you have to do is just set the Go OS environment variable or the Go Arch environment variable to what you want to compile for, and then just run the go build, and it will compile it for it. And this even works with the binary releases that you download from golang.org, which again, in 1.4 and before, that wasn't the case. Now, if you're using CGO, which is using C inside your Go code, you still have to bless it.
Okay. Now, if you want to do anything like cross-compiling, you can't just download the binary. You got to build it yourself to get that feature.
In 1.4 and below, you did.
Oh,
1.5, you can grab the binary and then just do basically that. So you're just setting an environment variable, and then when
okay,
you
so from 1.5 up, you don't have to do it. Just go
Yeah.
just download the binary. You can cross-compile.
yes.
Okay. Well, that is slick.
Yep. So what that means is I can be on this Mac, which is running OS X and using the AMD 64 architecture, and build out a binary that will run on a 32-bit Linux or a 32-bit Windows machine. It doesn't matter. And as with 1.5, 1.6 sees a lot of improvements to the garbage collector. So 1.5 introduced a low latency garbage collector in order to reduce the amount of time it took for everything to run. The new collector trades throughput for reduced latency. So it's not as thorough, it doesn't get as much stuff when it deletes it, but it does it faster. And when allocating memory, it takes a little bit longer for the system to do that now, but it helps it when it's cleaning up. And for 1.6, a lot of optimization and tuning has been put in to enable larger heaps to being able to be deleted within a 10 millisecond goal. So to have a look of it, this chart shows the garbage collector performance with Go 1.3, 1.4, and 1.5. So the y-axis is seconds, and the x-axis is gigabytes of data cleaned. So like looking at 1.3, the worst ever it did, it was cleaning up roughly 12, 13 gigs, and it took over 8 seconds. As it went on, this improved, and they've lowered those, but it still isn't the greatest, because when the garbage collector is running, it does what's called, it stops the world, so everything stops, so it can go through, find what it needs to clean and delete it. And for this to take seconds was bad. With 1.6, they actually got this down to milliseconds. So looking at the 1.5 here, again, for cleaning up roughly 25 gigs of data, it took a little bit over 50 milliseconds, whereas for 1.6, it's a little over 10 for that same 25, but at the same time, it's also doing 140 or so gigs in about 35 milliseconds. So this is a huge improvement over what we've had before. And Go 1.6 adds support for HTTP2, and there's nothing you have to do to enable this other than have your server be accessible via HTTPS, so have a SSL or TLS certificate, and the app being compiled in 1.6. And then as long as the client and the server supports it, it will use that versus the HTTP 1.
What's the difference between those two?
So one of the advantages between them is with the current HTTP standard, when you can make a connection to a server, everything gets transferred over one connection. So if you're connecting to a site, it's pulling the HTML and any assets that site serves, so JavaScript, CSS, images, they're all coming over one connection. HTTP2 actually breaks that out, so each thing that's going to get pulled across happens on its own connection, so it can happen in parallel. So if you're pulling a page that has 50 images on it, you're going to create 50 plus connections between you and that server and pull everything at once.
Just yeah, other than just having one pipeline.
Yeah, it's, instead of one massive pipeline, you have tons of small ones.
You probably notice the difference when you use that.
You actually already can. There's a demo site that's powered by Go that is the standard test for it. But because it's automatically enables itself, if for some reason your program cannot use that, you can set the TLS next protocol and tell it to not use it by setting it to a non-nil or an empty map, and it will not auto use HTTP2. So to see it work, like this is pretty much the test site for HTTP2, and you can hit it, and you can basically just go. So there's just various tests you can do. This is designed for testing not only your applications, but testing the protocol to report any bugs that you may have for it.
Okay.
But the key is right there.
Yeah.
And it's just http2.golang.org. So one change that does affect how using C code in Go works is the ability to share pointers between both. So now the Go's garbage collector can actually manage the memory that's used by the C code as well.
Okay.
And the way it does that is because both will be sharing the same memory space. There's 3 rules that have to be met in order for this to work, though. You need to pass a pointer has to be passed to the C as part of a CGO call, and I'll show you what that looks like in the next slide.
Yeah.
The memory itself cannot contain a pointer to a Go allocated memory, so it cannot be a pointer to a pointer.
Okay.
And the C code does not retain the pointer after the call return, so it can't be assigned to a global in the C code. These rules are checked by the runtime during execution, and if it detects a violation, it will print a diagnostic and crash the program.
So that means you can't write bad stuff and get away with it.
Yeah. This can be disabled by setting an environment variable go debug equals cgo check equals 0.
Okay.
And that will disable that check and allow it to continue even though it would normally crash.
Yeah.
But it's not advised to do that because you can have even weirder errors later on.
Yeah.
So an example of what this would look like, if you've never seen CGO code before, what you do is under the package declaration, you put in block comments, and in here is where you'd put all of your C code. So we're defining a function here that will return an integer, takes in a single argument, and does something with it. And in order for Go to understand that, you import the C library, and we're going to need to import the unsafe library as well. So that's our Go code and our imports, as our C code and our imports. As for our Go code, we'll define 2 different types. Both are structures, so we have a T struct with 2 fields, A and B, which are both integers, and an X struct, which is a pointer to our T structure that we previously defined.
Okay, now with chapter 13 of this book, I got an example of doing that stuff with that. And with that, similar to that.
It won't be doing memory sharing because
It won't
that
be the memory
yeah.
sharing, but I mean as far as the C code.
Yeah, as far as doing CGO, yeah, that will be in that Go book.
Yeah, right,
Because it is kind of an important thing to know and if you need it.
yeah, but you say if you don't need it, don't use it.
Yes.
Right.
It's like the best use case for it is if you're having to interact with something and there's a C library written for it.
Yeah.
Instead of, if you don't want to have to write a pure Go version of that, you can take that C library, pull it in, and then basically write a wrapper around that and use it. So as far as making this work, so we'll define two variables. One is our of type T that we defined, and we set a value to each one of the fields. And then we define our X, and because our X structure is a pointer to T, we create the pointer to our T variable. So this is what a CGO call looks like, this C dot and then the function name. So it uses reflection to be able to read in here to figure out what all functions and variables are available, and then they're all made available by the C library. So by calling c.fn, we're actually calling this function up here.
Okay. Oh, okay.
And so then we use the unsafe package to tell it that we're going to pass a pointer, and we pass it a pointer to our T, and then on the second line we pass the pointer to the X. Now if we review our rules, so our rules for making this work. So the first one, it must be a pointer to memory passed to C as part of a CGO call. Well, that is, so that checks out. It cannot be a pointer to a pointer. Well, that's not, because we're actually defining the values here. So that checks out. And the C code cannot retain the memory for the pointer after it returns. And well, arg isn't a global, so that's true. But as for X, well, we are passing it a pointer, but the X is a pointer to a pointer, so that would fail.
What if the C code actually does its own memory stuff?
Then that's fine as long as it's handling it in a safe way.
Yeah.
But with this, you don't have to worry about that because you can just let the Go garbage collector deal with it.
Okay.
So it's a way of injecting garbage collection into C.
Okay. But I'm thinking if the C code itself.
Yeah, if the C code does like mallocs and things,
yeah, right.
then that will be okay.
Okay. All right.
But let's see. This should fail with the X one. Yep. Runtime error. The CGO argument has a Go pointer to a Go pointer. So immediately the X1 has failed. So let's get into a bit of the toolchain. Externally, the compiler toolchain hasn't changed since 1.5, so that you won't really, there's one change that is noticeable. But internally, the parser has been completely rewritten, because in 1.5, what they did to get that was they wrote a program that would take C code and generate Go code, and that's how they got rid of the C. The problem is the Go code that created wasn't idiomatic Go, and it wasn't very performant, so it had major performance issues. And so with 1.6, they're actually starting rewriting some of that to make it much more efficient. And so the parser was the first one that they replaced. In 1.7, they're actually going to work on replacing the compiler, but that's only going to be for the AMD 64 architecture first. So the one change that is noticeable is using the -X flag when you do a Go build or Go install. What this does is this allows you to set a value of a variable or a constant at compile time. Very useful if you want to do things like have a build number or build ID that's programmatically generated by, say, your Git SHA that it was built against. You can write out a make script, a make file that will grab the commit SHA and pass it into the program using this -X flag and set that variable. So then when, say, an end user files a bug report, you can use that output to see what commit they built against. The old syntax for that, it took 2 arguments. So the name of the variable that you were replacing as well as the value. In 1.5, they added in a new syntax that did a single argument, but was more clearly a key value pair. So your variable equals value. In 1.5, the old syntax was still accepted, and the same for 6 or 1.6. But 1.7, the old way of doing that will not work. You'll need to update everything to use this new syntax. Another change is maps panic if you misuse them. So the runtime has a lightweight best effort detection for concurrent misuse of maps. A good way to put this would be if you have a map that is that multiple Go routines are trying to write to at the same time.
Yeah.
This would cause a race condition. Well, the runtime will try its best to detect such things and actually crash, reporting an error. So the error will be this concurrent map writes, which will give you an idea of what you need to do. And the best way to debug this is to run the program through the built-in race detection. And
you don't really typically have like throws in Go, do you, or much? Or
no, you don't have case switch, or you don't have the catch eval or anything like, or try catch.
yeah,
But Go will panic for major errors.
right, yeah.
And when it panics, it'll throw out a stack trace.
Right.
So an example of causing this would be here. So we set up 99 workers, and we define a wait group so the program will wait until all workers report that they're done. We create a map that they're going to be writing to. And so for all 99 workers, we're going to tell them to concurrently go through this I integer, which is the current number that they are, and it's going to loop over that and write into that map. And because we're going to have 99 different jobs writing into the same map at the same time, we are bound to have problems. And immediately, let's scroll past. Yep. It's caught that we have concurrent map read writes. So it's just not going to do it.
Oh,
And so if you do have problems with that, again, the built-in race detector is great for finding things like that. Another change is the panic messages are shorter by default. So whenever the Go program panics, instead of getting a stack trace for all Go routines, which can be anywhere from just a few handful to thousands to millions, it only will return the stack trace for the Go routine that caused the panic. So it will give you much more relevant data at much more condensed form. To do the old version to see all the stack traces, you can set an environment variable of Go traceback to see all of them, or you can use the debug.setTraceback in a point before it could crash or before it calls fatal and rerun it. So here's an example of something that could cause a panic. Again, this basically is, or this one, we're defining a set of workers. We're all going to concurrently do it, but here the problem is going to be the select. There's nothing for it to select on. It's just an empty select. So when we run that, it's going to just return us one instance of the stack trace rather than 99 instances that are meaningless. Another change that's Windows specific is in 1.5 and earlier, the Go runtime actually forced the Windows timer resolution to be at 1 milliseconds at startup. This turned out to hurt battery life on Windows machines.
oh,
So in 1.6, they no longer need to change the scheduled performance value, and so changing it's no longer the case. It won't do that anymore. So it should result in better battery life on Windows machines.
Now that means that time begin period was only for Windows.
Yes. On everything else, they did not have to manipulate the system's timer. It was just for Windows.
When did they have to manipulate for Windows? Or?
The way it works on Windows is so different than your standard Unix operating systems. It's just, it didn't work the same as the other operating systems. I'm not sure what they had to do underneath to get around that now without having to adjust the timer.
Yeah.
So Go 1.5 introduced experimental support for vendoring, which allows you to bring in third-party libraries that you're using and manage it yourself. That way you can control updating them and everything. In 1.5, you had to set this environment variable to be 1 in order to enable it. Otherwise, it wasn't enabled. In Go 1.6, it's no longer considered experimental, so it's turned on by default. And to turn it off, you set that same environment variable to 0. And in the next release, they're actually going to drop that flag altogether. So the main problem this may cause is in code bases that already have a directory called vendor, and the fix for that is just basically renaming that directory to something other than that. The way vendoring works, your program's source code should be in the Go path /source directory, and inside the root of your project, you just create a directory called vendor and put everything in there. So here we have two different code bases. One called server1 that has one source code, one source file. And in here we're importing the mux package from the Gorilla web framework. And in the second code base, server2, we have that same code, or that same file, importing that same library, except we're actually vendoring in the version of mux we want to use.
Oh.
So in server 1, it's going to use the global mux, so it's going to actually look in Go path source, GitHub, Gorilla, mux, and use that version. And the server 2 one is going to use the one under the vendor library. The import string is the same, so there's no change you have to do there. You just basically add in the directories and do a git clone there. And then these can be sub-repositories if you want, or just managed in the same Git repository, or if you use Mercurial, if Mercurial has something equivalent to a Go sub-repository, it doesn't matter at that point. So one gotcha could be is if you do something like go test dash ... When you do the dash the dot slash ... that tells the Go runtime to act on everything in the current directory and recursive all subdirectories underneath.
Oh, okay.
This could be disastrous if you are using vendoring and you're not using the paths correctly. So don't use paths like Go path, GitHub, your username, your repository vendor. So basically this bit you want to avoid. Another thing, 1.6 will actually work with Clang and the LLVM instead of just GCCC. And one advantage using the LLVM is you can use that to do the memory sanitization. So much how Go has the built-in race detection. If you use CGO, you can use the LLVM to analyze not only to analyze the C or the C++ code and do that same level of checking against that. And all you need to do that is to pass the -MSAN and that will tell it to do the memory sanitization. This will require that the system has Cling installed. So if you only have GCC, this wouldn't work. And this is also considered experimental and only available on 64-bit Linux machines.
What do you say if you only had GCC, it wouldn't work?
So GCC is the GNU's C and C++ compiler, but there's also Cling now. And Cling uses the backend compiling engine called LLVM to do it. So it's another C and C++ compiler, but it does things differently than GCC does. And one of the advantages is it gives you race detection and things.
So that means that when you're doing this stuff, you would want to use Cling instead of GCC? Or
if you're using CGO, you'd probably want to prefer Cling over GCC.
Okay, but it wouldn't matter on other systems besides Linux AMD.
This is the only thing that would require Cling over GCC.
Okay.
As far as just building Go code with C in it, GCC works just fine. It's just GCC doesn't give you a race detection and things. That one didn't get to couldn't come up with a good example for the shared library supports. But dynamically loading code at runtime, or basically what some languages will call a plugin, isn't supported in Go yet. There's talks about doing it, but just that hasn't been implemented. I meant to drop that slide from this actually. As far as performance, on average, the programs will run a few percent faster in 1.6 than they did in 1.5 and before. The garbage collector pauses are even lower now, so that helps out quite a bit. But the effect of the garbage collector, it probably would only be noticeable in applications that use large amounts of memory, probably gigs worth. There's been other optimizations in some of the libraries, like the bzip and gzip, as well as some of the cryptographic libraries like AES and the Ecliptic and ECDSA. And the sort package has seen a huge improvement. So for sorting, the new sort implementation has been rewritten, and it's now makes 10% fewer calls to the interface's less and swap methods than it did previously, and that makes a big difference. The new algorithm chooses the ordering differently than the way it did for values that are equal. So in 1.5 and before, if you had two values in an array or a slice that were the same, they would always return in the same order if you constantly rerun that. In 1.6 and before, that order isn't guaranteed.
No, okay. 1.5?
1.5 and before, they would return the same order if it had matching.
Yeah.
In 1.6, that's not guaranteed. They could change.
Now, they said there were reasons for doing stuff like that because I think it's something in relation, like, for example, key values pairs is like kind of randomizing it so that you wouldn't depend on what a particular implementation does.
Yeah.
Yeah.
But as well, it goes to the last paragraph. So programs that did require it to return the same would need to use the new stable function, which basically is the old sort method.
Yeah.
So here's an example of how that works. So if you've never done sorting in Go, so we declare a structure that we call people. So we'll have first and last names, and we define a custom string method on that so when you print, it will print out in this format. And we declare a second type that's a slice of our people, and it is customary in Go or idiomatic to name this type by what it's going to be sorted by. So since we're going to sort by first name, we name this type by first name, and that comes into play later on. So the way you do sorting, you declare your own length method, your own swap method, and your own less method. So the length method, it just returns the length of the slice or the length of the array that you hand it. The swap method is actually what's going to swap A and B. And then the less determines if A is less than B, or so on and so forth. And you can actually, if you want to do fancy logic, so say if both first names matched and you want to sort on last name, then you can add that logic into this less method. And so in our main is where we actually define it. So we'll define a slice of people. So we have Bill Clinton, Romeo Capulet, Bill Cosby, Juliet Montazag, Bill Gates, Walter White, and April O'Neil. And so we call sort by first name people, and that's when the sorting is going to happen. So even though this is the order that we have now, when we run it, we'll have our slice nicely sorted. Now, since we're sorting by first name, the position Bill Cosby, Bill Gates, and Bill Clinton isn't guaranteed. Although in this case it did seem to do the same. So another nicety, if you're doing anything with templates, either for text output or for HTML, with 1.6 you can strip whitespace with the template engine now. So what this does is it will make the template code, the result of the template, a little bit more readable. The way you do that is you add a minus sign at the where you want to remove. So putting the minus sign at the beginning of an action says to trim this space before it, and putting a minus sign at the end says to trim the space after. So here's basically a template definition. So we have a range because we're going to give it a list of things, so it's going to go over the list, and we're going to trim any white space after this. We'll print out each item in the list, and then trim space before it, and then close out the range. And so here we're going to tell it to run, giving it a list of things. So it's going to have Mars, Mercury, Pluto, Neptune. So when we do this, it's all going to be one line because we told it to strip all space. Before, if we were to take out these, then they would have each been printed on their own separate line. Another change to the templating engine is it has support for block actions, and this allows for redefining things inside a named template. So example would be here. So this is basically HTML. So we'll have a title, and we define a block title, and then we have this page title in here, and same for down here for the page, and that has main text. And what this allows is you can override what's in here and what's in here within your program. So these can be like a default value, and then you can change these programmatically just by updating or telling the template engine to replace what the title or the block title and the block page. So it makes it more flexible and makes it more like templating engines that everyone's familiar with. The govet command has had a bit of a change. It's now diagnoses passing functions or method values as arguments to something like a printf, where when you forget to put in the parentheses at the end. So here, in this example, we're going to print out hello and the user agent of whatever browser hit this server. So this would actually lead to an error because user agent is not a variable, it's actually a method on the request type. So in order for that to work, it would have had to be that. GoVet would find and report that error now. It didn't previously. So the GCC Go project, the release schedule for GCC and Go do not coincide. So GCC 5 is the most recent version of GCC out, and that supports Go 1.4. The next release will have 1.5 support. 1.6 isn't likely to be seen in GCC until their 7th version. And that's just because of when the project's released. So by the time Go is getting ready to release their next major version, GCC is already in a feature freeze and they can't pull that in. And then the standard library has had some minor changes, some big improvements, some big improvements, some not so big. So to cover a few of these, the archive tar package has gotten a lot of bugs and rare corner cases and file formats fixed. One visible change is the reader's type read method now presents the contents of the special file types as being empty, and this allows it to return the end of file immediately instead of having to wait. The buff.io's scanner type now has a buffer method, and this way you can specify the initial buffer and maximum buffer size to use during scanning. This way you can reduce the buffer overflow issues. It also is possible to set tokens larger than the token size, because the scanner's only reads in a certain amount of bytes before it will cut off, and you can up that now.
Oh.
And then also there's two new error values. So there's a error final token error value, which allows it to tell the program to be told when it hit the end of the tokens. So here's an example of showing changing the max token size. So we'll define a variable of bytes buffer, so it's going to be a byte space, and then we write to that buffer a slice of bytes of Go 1.6 is awesome. And before 1.6, the max token size is 64 times 1024, but we can change that now. But to basically make an error happen, what we're going to do is we're going to create a line that's 1 byte longer than the max allowed size by default. That's 24 times 1024, or 64 by 1024. And so we're going to write that out. And if we were to try and call the scanner.scan, we would actually error out with this reading long lines buff.io scanner error here.
Yeah.
But now we can basically say this, and that's going to up the buffer size. It's going to double it. So it's going to be twice as big as what it was before. And that's plenty of space for us to read in that very long line, plus this original string that we put in the memory.
What exactly do you mean by token?
So one of the ways Scanner can work is it can read in a line and then break it out.
Yeah.
So you can say, I want you to read in this line and then return everything by words. So it will return each word on that line as well.
Right.
So a token is basically like a word or whatever you tell it to do.
Well, that's a huge token at 64 times 1024.
Yes.
Still pretty big.
Yes.
So you get,
And if you ever hit that point,
Yeah.
the program would have panicked.
yeah.
And so if you're dealing with cases like that, you can increase that limit.
If you ever need to.
Yes. It's highly unlikely that you would, but in case you do, you can. And for them to implement this, someone at some point has hit that max token size.
Like passwords or something. It's just.
Yeah, maybe. So on top of the HTTP2 being added, some other changes in the net packages is the file server now sorts the generated directory listing by file name. Before it was a random order, which was just kind of annoying. The net client now allows user code to set the expect header. So say the expect 100 continue header or others. And you can see the list from the transport.expect package. There are 4 new error codes from the RFC 6585. These are status precondition required, or 228. Status too many requests, which is 429. Status request header fields too long, 431. And status network authentication required, which is 501. I don't know if these are actually new to the spec or if these are just new to Go, but they have been added. And then implementation documentation of close notifier has been changed. This is kind of more of a use case for a hijacker interface, something not everything's going to do, but I don't know a good way to describe how a hijacker works. The Go documentation actually has examples of one, though. Let's see. HTTP examples. Yeah. But yeah, so if you're ever needing to implement a hijacker, which it looks like it would just inject itself into a request, but the close notifier can now work with the hijacker.
What is the purpose of a hijacker?
Yeah, I'm not sure. I've never had to implement it. I'm not sure why you do this. Yeah. I've never actually had to implement it, so I've never had experience doing so. So some more changes to the net libraries. The net HTTP test package, the response recorder, now initializes the default content type header. It uses the same algorithm that the HTTP server does. This way it will automatically set the content type, whether it's text or if it's an image or anything like that. That will get set automatically. The net URL package parser is now stricter and spec compliant regarding parsing of host names. Like previously, host names with spaces would actually get through the parser,
But then
even though they're not valid.
they won't work.
Yeah, that's no longer the case. It will find things like that and reject them. And the standard error type has a more standard error interface, because previously the net URL error and net error were slightly different. So the net package also implements two DNS resolvers. The one that was in 5.4 and before is actually a Sego based resolver which uses the platform's DNS, and in 1.6 it introduces a PureGo DNS resolver, and you can set which one to use by using the Go debug flag environment variable. So with 1.6, the Sego based one is used when not cross compiling, and the PureGo one is used when you're exclusively cross compiling. But you can force one or the other by doing the go debug equals net DNS equals go, or net DNS equals Sego, depending on which implementation you would rather use. Performance wise, this one would act, the Sego one has to make a system call to the system to do the DNS resolution, whereas with the PureGo, that's not the case. So the PureGo may have some performance benefit. The OS package, the is exist, is not exist, and is permission checks now return correct results when inquiring about a syscall error. So if you try to do a stat on a file that doesn't exist, the is not exist checks will it returns what's considered a correct result. Before it wasn't a standard, I guess you would say.
If you were trying to access a file that didn't exist, or you didn't have permissions for, wouldn't you have previously needed that information?
Yes, those existed, but if the is not exist or is exist calls returned was very Go specific rather than being more traditional.
Yeah.
So normally you'd get an error code or some error code, an integer, so a non-zero value. Go actually returns different results. So they've standardized that, so it will return the non-zero integers. On Unix-like systems, when you make a write out to the OS standard out or OS standard error, basically the file descriptor 1 or 2, if you do like piping and things, if these fail due to a broken pipe, the program will raise the sig pipe signal. By default, this will cause the program to exit. It could be changed by calling the OS signal notify function and for the sig pipe and changing that. I'm not sure why you'd want to do that though, because the sig pipe is pretty bad, because you can't write out to standard error system out if you need to. But so yeah, those will actually return those errors signals.
Right. So that means if the sig pipe doesn't work and you can't write to standard error, then you write an error message to standard error.
Well, it will actually return with the proper value, whatever the sig pipe is. I don't know what the error code for that is, but it's actually going to throw that error code to the operating system. So the program will die and throw the non-zero value to indicate
you get back
sig pipe.
Yeah, back from the execution, right?
Yeah.
Right.
So the old way of doing it, of raising an uncatchable sig pipe error after 10 consecutive writes to a broken pipe, no longer occurs. So it will die faster, pretty much.
Okay.
The regex package has gotten quite a bit improvements. for some highly concurrent servers, using the same regex pattern for many Go routines has had degraded performance because for memory issues. The way the regex works on this is it creates what's called a scratch space, a place in memory where it can do the evaluations to see if what's it handed it matches the pattern, and this could get full, causing the system to not be able to work as well. To help such servers, the regex now has a copy method, which will make a copy of the regex and create a new scratch space so it can do more operations at the same time. But this does have an additional space overhead because you're basically making a second copy of that memory that it uses for it. So it should only really be used if you notice degraded performance on a lot of regex. And this is an example of what it would look like. So you give it a regex pattern and you assign that into your variable, and then you just do a copy to create a second one. So now you can round robin between the two effectively. The time package parse function has always rejected any dates of a month that's larger than 31. So like say January 32, it knew immediately that failed. In 1.6, it now also rejects February 29th and non-leap years, as well as like February 30, February 31st, April 31st, June 31st, and other months that have...
Before that, it didn't reject them?
No.
Oh, okay.
It would do the math behind the scenes to correctly count. So if you handed it, say, April 31st, it would know there's no 31 days in April, and go ahead and switch over to be the May plus 1st. One. Yeah, May 1st. Yeah, okay. So it would do that behind the scenes. Yeah. But now it's just going to flat out say, no, that's not a valid date.
So you probably made a mistake.
Yeah. So like here's an example. We're going to try and tell it to parse it February 29th. Right. And so we'll define a timestamp and tell Go to parse that. And of course, when we do that, it's a day out of range. Right. It doesn't exist in the calendar, or at least because it's not a leap year.
Not even in Australia.
Yep, because everything's backward in Australia. We're upside down, either way. But that's some of the major changes to 1.6.
Well, you should grab it as soon as it comes out.
Yeah. The last, let's see.
Hey, Adam.
Yes.
While you were talking, 1.6 actually got released.
So we were figuring that'd be the case because in one of the subreddit, in the Golang subreddit, they were talking about, so the draft tag was removed, and there's no more open issues, and so we were wondering if they were going to wait until the release parties to do it. So well, yes, 1.6 is out.
I installed it while you were talking.
Is it on golang.org?
Yes, so if we go to golang.org.
When we first started chatting, I looked and it wasn't there.
Yeah.
And then for some reason I looked again halfway through and it was released.
A few hours ago.
Well, they did it while we were talking.
I was looking just now, but it didn't even come.
And they even redid the website because the website is actually a Go application. Yeah. And so while we were talking, they've released it and also rebuilt the website.
Yeah.
I was watching that featured video where he's saying that 1.1 wasn't out yet.
Yep. Well, now it is. I guess we can live go from 1.6 RC2 to 1.6.
Also, if you take a look at Drupal.org/planet, Drupal Camp Chattanooga's on the first page. There's a picture of us there.
We'll do that one first, then. So /planets.
And it's a pretty long page.
I'll do that.
Go down.
So
Gotta go. It's a good way down.
DCCH. Hope if I can type. CCH.
I think just find Chattanooga.
Yep, there we go.
Scroll down a bit. You go.
Hey!
Hey, look at there.
Is Sean in there somewhere?
I'm
Is he
in there. Yeah.
Yes, Sean should be in
Right
here.
behind you.
Yep, right there.
Up there he is.
Sure. Yeah.
Okay. So
That's cool.
since I have it compiled from source on this one, I need to grab this. Copy this link address. While that's doing that, starting up, let's see. Oh, it's not tmux crap. Okay. Let me fire up a second terminal then, because that's not running a tmux session. Just go see. Alright, so let that download and get fetch. And get checkout go 1.6. Alright. Let's see, what is the flag I have to set? Let's check the tarball. So if you're going to compile Go by source, you have to have a version of Go existing.
Yeah.
So you need 1.4 or higher. So I grabbed the 1.5.3 in pre-compiled versions.
Yeah.
I just extracted it. And so I can get rid of that tarball now. And then we need to...
You just download it so you can get rid of it? Or?
I deleted the tarball because I already extracted it.
Yeah.
So I'm going to build it from source.
Okay. Oh, okay.
Equals /go, and then it is alt.bash. Yep. So it's going to go through, build the compilers and things it needs first. Set up using the pre-compiled one to do it.
Yeah.
So it's setting up the Bootstrap environment right now.
So that's why you downloaded the older one.
Yeah, because it needs Go to compile Go.
Mm-hmm. Oh.
Yep. Now it's actually compiling itself.
So that means that you could use Go 1.5 to compile 1.6.
Yes.
Look at the smile on Adam's face. It's like Christmas.
It means I have a lot of things to update, like my website.
Yeah.
So right now, this doesn't support HTTP2, but tonight I'm going to recompile it so it will.
All right.
But yeah. So this is in Go as well.
Before and after. Just to see. Yeah, that'd be cool.
But that's cool that we made it on the Drupal.org planet.
Mm-hmm.
Let's see. Is it that one guy's... oh yeah, that was from the Chromatic.
Yeah.
That one guy that posted from Chromatic, how that was his first camp.
Yeah. I read it quite a while back, but it's only just
Yeah, he posted a couple weeks after the camp.
It must have been redone. I'm expecting republished or something.
I don't know.
Well, this looks like a different article.
Because it was published today.
Yeah, that's the one I remember.
Oh, well, it says a few weekends ago, though.
Yeah.
Been a little longer than that, hasn't it?
Yeah.
Yeah, your today and my today are different now, Adam. Where I am, it's now the 18th.
Yep. Now it's day for Drupal for you. But yeah, I'll send out the email tomorrow with the address and everything.
Super.
So, Adam going to handle it, or are you going to teach it from there?
I'm running it. I'm going to run it, and Lee's going to join us via Hangouts again.
Cool.
So what was the consensus?
The topic has pretty much been let's do rules because Bill is doing a lot of.
Everybody wants rules, yeah.
You should let Bill drive it then.
Well, Charles also has questions about deleting nodes with rules, and we've used the node expire before, and so I can run that bit going over node expire and how to use rules to be able to act on that. But I think I'll probably let Bill drive bits of it too, so he can go over different things he's used rules for.
Yeah, I used to have a 3-part rules one, which was like an intro to rules, how to write your own rules.
Yeah, that slide deck that had your face in it.
I remember that.
The British are coming. Is it Lee? Just bring beer.
That's okay, bring beer, yeah.
So now we're into the unit testing. This usually takes a little bit. But everything's already been compiled. It's just doing its tests.
Yeah, just on a whim, I looked at Drupal Planet. I haven't looked at it in a while. There's quite a lot of interesting Drupal 8 stuff on it.
I have the Drupal Planet pulled in via RSS, but at 10:30, although the time zone's weird, 10:36 p.m.
Mm-hmm.
But yeah, it would not have been in my feeds when I've checked it then.
Actually, if you look at that, if you look at like all the top ones on that, everything's posted by Chromatic. If you look at it,
I wonder if Chromatic did something on their blog then.
Obviously, they got their Drupal feed just working.
Yeah.
Yeah, so it just pushed everything they had.
Yeah, it pushed all to
It's
Planet.
They're all at the same time.
Yeah, there's a whole bunch. They've got some interesting things on there.
10:36. I wonder if we go to their site though and check the actual time this blog post was, assuming they're one of the same people that still have. Yeah, there we go, January 8th. So they must have just kicked it or got it working or something.
Yeah, this was November 17th, 2015 for the Drupal.
Oh, for our camp?
Yeah. That's when
Yeah.
I posted it the first time.
Yeah, Chromatic did something to take over the Drupal Planet.
We're okay with that.
Just means that we need to get on the ball blogging and do the same thing.
Yeah, we really do.
I can build your website in ASP.NET.
We'll pass.
I'm so sorry.
You do have our sympathy, though, Sean.
Well, luckily, all I'm doing is straight HTML and less, and I'm building it in their CMS. I'm going to the transformation and just writing. I'm not even building or using anything that they actually have implemented. I'm just kind of bypassing all that because the website was already built. All I'm doing is like creating new templates and pages. He's like, just do straight HTML and CSS, and it's just like a space that accepts markup. So I've not had to really do anything in it.
What was that window manager you used, Adam?
Do what?
The window manager?
This is KWM. Let's see if it's going to be the first hit on here. Yeah.
Is that what you're using up there?
Yeah.
I was wondering about that. It's nice looking.
And so it's a tiling window manager where the focus follows the mouse. So you'll see the little green border switching.
Mm-hmm.
Because I'm a huge fan of tiling window managers. All of my Linux and BSD machines at home use a tiling window manager.
So I'm using
Although that one is this, and every time I pronounce it, people kind of like, your computer has what?
I'm using Moon, which just is a window, manager.
Hmm.
Tyler, you hover over this, you put,
Oh. Oh.
it's workable. But I like that highlighter.
But this is what I run on my Linux and BSD machines.
What? Okay, I'm not going to attempt to say that.
So now we're on race detecting. The tests seriously take forever, but everything's already been compiled.
The guy from Chromatic that did the talk on doing that kind of stuff, they've implemented it on their website.
Interesting.
He did it at our camp and
Was that Ryan?
Ryan, yeah, and Asheville.
What's his last name? I can never remember.
Let's see.
I feel bad because I'm horrible with names.
Ryan, too.
Yeah, I like run into him at pretty
He's
much
on my
all the
Twitter
camps
feed.
and at
Haggerty.
cons.
Ryan.
Ryan Haggerty. Okay. Yeah, because pretty much all the camps we go to, I run into him at least once, and I run into him at DrupalCon, and I can just never remember his name.
I never remember anybody's. Yeah, I like how they did their little menu.
Well, while we're doing this, also, so let me load these up because there's a URL for the very important bits. And just let me jump to that last slide. Come on, Google.
And while running Hangouts, I only get 3 hours battery life.
Yeah, that's definitely insane. But anyways, if you want a chance to win your choice of an Android Wear device, an Android tablet, or a Chromebook, please fill out the survey linked there at goo.gl NUAEUE, and you'll get and put in the quarterly draw for it, as well as I get my own different draw put in for a draw. So please fill out your surveys.
Forget that every week. Every week.
Well, fill it out now.
I'm gonna do it right this minute.
And while you're doing that, it is done compiling and done testing. And if we go version 1.6,
Okay.
which means I can get rid of that pre-built one I just downloaded. And I will kill the stream.